Hello friends, welcome to online studies of Ashadeep International School. Subject Mathematics, Chapter 2, Polynomial, Standard 10. Let's start with the basics. So, let us start with the degree of polynomial. Let us start with the degree of polynomial. So, what is the degree of polynomial? So, it is nothing but the highest power of polynomial. It is the highest power of the polynomial is called the degree of the polynomial. Okay. So, for example, what is the highest power? So, let's check this example. Right. So, here the first power is 3. This is the 2, and this don't have any power, so it is a constant term. So the highest power is 3, so the degree of this polynomial is 3. Right. Now let's talk about the second example. So here the power is 2, power is 4 in this example. Right. In this example, 6x square minus 5x power 4 minus 5. So what is the highest power? So the highest power is 4. So that's why degree is 4, and degree is denoted by capital D. Degree is denoted by capital D. Okay. Now types of polynomial. If we are learning the polynomials, and we must know the types of polynomial. So let us start with the linear polynomial. Linear polynomial means what? So the degree is 1. If I write down here that 2x plus 3, so here the highest power is what? 1. So the degree is 1. So therefore that is called the linear polynomial. Right. Quadratic equation, if the degree is 2, then it is called the quadratic polynomial. So if I write down here that 5x square minus 3x plus 1, so what is the highest power? So highest power is 2, so that is called the quadratic polynomial. Now we must know the generalized form. So what is the generalized form of linear equation? So that is ax plus b is equals to 0. The condition is a must not equals to 0. Why a must not equals to 0? Because if a is going to be the 0, this term is going to be the 0. So the only term remain, that is b, and that is called constant polynomial. If only constant term is there, then it is called constant polynomial, right? So that is called constant polynomial. If the constant term, if only constant term is there, then it is called constant polynomial. Now then cubic, simple. Cubic means what? The highest power is 3, degree is 3, then it is called cubic polynomial. Similarly, biquadratic means the degree is 4. Okay, so I hope you must clear with the degree of polynomial. Now let's move ahead. Geometrical meaning of degree of polynomial. Geometric meaning of degree of polynomial. So what is the geometric meaning? So before started, let's see one example, and that is minus a real number. Here is the definition. Real number k is the 0. Real number k is the 0 of the polynomial p of x if p of k is equals to 0. Now what does it mean? It means, let's understood with the example. Here we have a polynomial p of x is equals to 2x plus 3. Here we have the polynomial p of x is equals to 2x plus 3. It is also called the y, p of x or y. Okay, then I can say here minus 3 by 2 is the 0. So how can I justify that statement? So instead of this x, we have to put minus 2 by 3. Here I put minus 3 by 2. So 2 and 2 cut. So what remains? So remains is minus 3 and plus 3. So minus 3 plus 3 going to be the 0. Minus 3 plus 3 0. So therefore minus 3 by 2 is the 0 of the polynomial. Right. Now if I wants to know the geometrical meaning. Geometrical meaning means what? I have to plot this polynomial onto the graph. So for that, I'll take any number. As we already know, as we already learn in the standard 9, I have to take any value of x. I have to take any value of x. Here I take, for example, in this, here I take 2. Here I'll take 2. If I put minus 2 instead of x, so let me show you. It's a 2. See here, I'll show it already. Instead of x I have to put minus 2, right? So I put here 2 2s are, so it's going to be the minus 4 plus 3. So minus 4 plus 3 is equals to minus 1, right? So in the same manner, we have to put now x is equals to 2. So we get 2 2s are 4, and 4 plus 3 is going to be the 7, right? So similarly, I'll get here the 2 points. So I have to put these 2 points on the graph. So here are those 2 points. The first point is minus 2 minus 1. So this is the minus 2 minus 1. And another point is 2 7. So here it is 2 and 7. Now I have to simply join this 2 point, and it is clearly seen that this line intersect the x-axis at only one point. So minus 3 by 2 is the 0 of the polynomial. So we can see here with the help of graph, that is called the geometrical meaning of 0 of the polynomial. Now let's move ahead. Now let us look for the geometrical meaning of 0 of the quadratic polynomial. Geometrical, the same thing, this I just repeat here. Another example, the first one is the linear. Now we'll see the quadratic, right? So the quadratic polynomial. So quadratic polynomial means what? Degree is 2. Now what kind of a graph we'll get with the help of quadratic equation? It's a parabola. It's a parabolic graph. So here I mention this condition that a is equals to 1, and that is greater than 0. What does it mean? That I will just explain you in a few minutes. But before that, I need at least 4 points to draw this graph. So I'll find here lots of points. In the same manner here, so how can we find it out? In the same manner that we find here, right? So the same manner we have to find out the points here. So how? So first I'll put, instead of x I put minus 2, so I'll get 6. Instead of x I put minus 1, so I'll get the 0. So similarly we can find out the other points, and those points are depicted in this table, right? So now I have to plot this point on the graph. So minus 2 6, this is the minus 2 6, then minus 1 0, this is the minus 1 0, then 0 minus 4, where is the 0 minus 4? 0 minus 4, 0 minus 4, here it is 0 minus 4. 1 minus 6, here it is 2 minus 6, here it is 3 minus 4. Similarly the points are there, and we'll get the parabolic graph. Now let's move ahead. Here I said greater than 0, right? So why I need to know this? Because if the value of a is greater than 0, see here in this, a is 1, because a is what? The coefficient of x square, so here I'll get a is equals to 1, that is greater than 0. If it is greater than 0, then graph is parabola open upwards. It's a open upwards. Why open upwards? See this is the open upwards here in this graph. This is the open upwards, right? So now what is the downwards? Let's see. Now let's see in the another example. This is the example 2, and here the value of a is minus 1. The value of a is minus 1, and that is less than 0. Now similarly we have to find out the 4 different points to plot the graph. So as earlier we see in the earlier we see the same manner we have to find out the points. So first of all I have to put 0. I put here 0, so this is the 0. So if I put 0 instead of x, what is the value of y or p of x? That is going to be the 2. Here I put -1. If I put -1, then it is going to be the 0. If I put 1, I'll get 2. If I put 2, I'll get 0. Simply we have to replace the value of x. If I replace here 0, I have to put 0. If I replace here 0, I have to put 0 in this polynomial, right? Okay, now here I say it's a less than 0. If it is less than 0, then the graph is parabola. Sorry, it's by mistake, it is going to be the downwards. Parabola open downwards. It's an open downwards, right? So it's a parabola open downwards. Now -1 0, here it is -1 0, 0 2, so here it is 0 2, 1 2, here it is, it's a 1 2, then 2 0. So those 4 points are plotted here, and with that points I'll draw this graph, right? So this is the parabola, open, but open downwards. It's an open downwards. So these are the two examples, right? So if it is greater than 0, it's an open upwards, and if it is less than 0, it's an open downwards. But it's a parabola, that you must have to keep in mind, then it's a parabolic graph. Now let's talk about now we have some different cases. We have to deal with the different cases. The zero of any polynomial are precisely the x coordinate. The zero of any polynomial are precisely the x coordinate of the point where graph intersects the x-axis. That means what? If the graph intersect x-axis at one point, then that polynomial has only one zero. If it intersect x-axis at 2 points, here this is the 1 point and this is the 2 point. So this graph intersect the x-axis at 2 points. So this graph has two number of 0. It does not much. We don't have to bother if it is going to intersect with the y-axis or not. See, it's whether it is intersect the y-axis or not, it doesn't matter. We just have to go through the x-axis. If it intersect the x-axis at 2 points, it's have a 2 0. It's a from this graph we can say one thing, that is value of a. So value of a is less than 0 for this graph. Why? Because it's a downward parabola. And for this point here, it is also touches at 2 points. So it has a two number of zeros, but it's an open upward, so the value of a is greater than 0. So those simple and small things you must have to keep in mind, right? Let's move ahead with the second case. This is the second case. So what is the second case? The second case is nothing but it touches the x-axis at only one point. So it has a 1 0, simple, right? Here the graph cuts the x-axis at exactly 1 point, so number of 0 is 1. Now case 3. See, case 3 is a bit important. Why? Because here we see that it touches the y-axis at one point. Sometimes we do mistake that it touches the y-axis, so it must have 1 0. But what is the condition? The zero of any polynomial are precisely the x coordinate of the point where the graph intersect the x-axis. But here it does not intersect the x-axis, so it does not have any number of 0. And from this graph what we can say, the value of a is greater than 0. And from this graph what we can say, the value of A is less than 0. So those simple things must keep in mind. Now let's move ahead. Okay, now let's see the graph of cubic polynomial. The same manner we have to find out the different points. We have this polynomial p of x with us, and that is x cube minus 4x. See, if I replace the value of x instead of minus 2, say, so it is going to be the minus 2 cube minus 4 into minus 2, right, is equals to minus 8, minus into minus plus, so plus 8, right? So minus 8 plus 8 is equals to 0. So here I'll get these 2 points, right? So similarly, if I'll put minus 1, I'll get 3. If I put 0, I get 0. If I put 1, I'll get minus 3. If I put 2, you'll get the 0. You just can try with yourself, because maths is all about practice. If you practice more, you'll get the more marks and more understanding, right? So those points are plotted here. The first one is minus 2 0, another one is minus 1 3, another one is 0 0, so that is here its origin. 0 0 is nothing but the origin, right? Then another point is 2 0 and 1 minus 3. So with that help of, so here one thing you need to notice, these graph intersect the x-axis at 1 2 and 3. So this graph intersect the x-axis at how many points? It intersect the x-axis at 3 points. So the number of 0 of the cubic polynomial here in this example is 3. So you need to notice one thing, right? Maximum number of 0. Maximum number of 0. So what are the maximum number of 0? So if it is a linear equation, then the maximum number of 0 is 1. If it is quadratic equation, the maximum number of 0 is 2. If it is cubic polynomial, the maximum number of 0 is 3. And if it is biquadratic equation, then maximum number of 0 is 4. It's a maximum number. It might be less than that, but it definitely not more than that, right? So if I consider the cubic polynomial, the maximum number of 0 3, it not go beyond 3. It is not going to be the 4, not going to be the 5. That is wrong, right? It must be 3 or less than 3. That might be 2, that might be 1, right? So that thing you must keep in mind. The number of 0 of the cubic polynomial is 3, quadratic is 2, linear is 1, biquadratic is 4, right? Okay, now let's move ahead. Okay, now let's see the exercise 2.1, right? We just simply need to find out, see, what is the question? The question is, the graph of y is equals to p of x are given in the figure below. For some polynomial p of x, find out the number of zeros in each case. So let's talk about the first one. This graph does intersect the x-axis at any point? No. So the number of 0 is 0. See this graph, the second one, this is the first, this is the second. In the second, the graph touches the x-axis at exactly 1 point. So the number of 0 is 1. Now let's talk about the third graph. So the number of 0, it intersect the x-axis at how many points? 1, here 2, and here 3. So it exactly touches the x-axis at how many points? 3 points. So the number of 0 is 3. Here in this graph, it touches the x-axis at 1 point and 2 point. So in the fourth question, number of 0 is 2. Here 1, 2, 3, 4. So in the fifth example, graph touches the x-axis at 4 points, 1, 2, 3 and 4. So number of 0 is 4. Now in the last question, the graph touches the x-axis at 1 point, at 2 point, and at 3 point, right? So the number of 0 in the sixth example is 3. So this is what all about the today's session. We'll go to the basics of the polynomial. So let's get quick revise. Let's get the quick revision of it. Let me go to the very first slide, and that is the polynomial. So here we just go through the let's take the small revision what we learned today. And we learned today is linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial, right? So the generalized form is ax plus b for the linear equation. For the quadratic equation, it's ax square plus bx plus c. So what is the highest power? Highest power is 2, and that is called degree of the polynomial. Cubic polynomial, and that is ax cube plus bx square plus cx plus d, right? I hope you get it. So the highest power is 3, so the degree is 3. So these are the basics. And for the biquadratic, the highest power is 4, so the degree is 4. Now we need to know the geometrical meaning of polynomial. If it touches the x-axis at 1 point, then it has a 1 0, right? Similarly, in a quadratic equation, if the value of a is greater than 0, then it is parabola open upwards, right? If the value is less than 0, then it is a parabola open downwards. Now the 0 of any polynomial are precisely the x coordinate that I already said, that x coordinate means if it touches the x-axis at 2 points, then it has a 2 0, right? It has a 2 zeros. Here it touches the x-axis at 2 0. From this graph, what we can say about the a? So for the first graph, a is less than 0. For the first graph, a is less than 0. For the second graph, a is greater than 0. Similarly here, it touches at only 1 point, so it has a 1 0. It has a 1 0. Here, the value for this graph, a is less than 0. For this graph, a is greater than 0. Why? Because it's an upward, and upper one is the downward. Here, in this case, it does not touches the x-axis, so it does not have any number of zeros, right? Here in the cubic polynomial, first of all we have to find out the points. We have to plot those points, right? And accordingly we have to find out the graph. It touches the x-axis at 1 point, 2 point, and 3 point, so the number of 0 is 3. Number of 0 is 3, right? Here we see the examples. It does not touches the x-axis, so graph is 0. Here touches at the 1 point, so number of 0 is 1. It touches the 1 point, 2 point, and 3 point, so it has a 3 number of 0. It touches exactly at 2 points, so this graph has a 2 number of zeros. it touches the 1, 2, 3 and 4 points, so the number of 0 is 4, and it touches at 1 point, 2 point and 3 points, so number of 0 is 3, right? So this is what all about today. Thanks very much. We'll see in the next lecture. So till then, bye bye, stay home, stay safe.